Okay, we're going to take a quick look at the number line from negative infinity to positive infinity and beyond. This is all about where numbers fit on the number line. Rational numbers like 1/2, 3, 100, -7, -93/3, they fit on the number line in different places. 100 doesn't show here, and -7 is there, and -93/3 is the same thing as -31, and it wouldn't show on the number line either. All right, so irrational numbers fit on the number line. Pi fits about there, and square root of 2 fits somewhere between 1 and 2. Square root of 10 negative fits about right there, and e, a number that's used in higher level mathematics, fits there about on the number line. And these are all irrational numbers. We'll take a look at irrational numbers here in just a few moments. Square roots fit on the number line. This is a perfect square root. Square root of 9 is exactly 3. But the square root of 88 is a little bit more than 9 and is there on the number line. Fractions fit on the number line. 3/4 fits about there. 7/2 fits about there. -9/2 fits there, and -12/7 would fit about there on the number line. Percentages fit on the number line, and so about 500% falls exactly at 5, and -306.2% would fall about there on the number line. Decimals fall on the number line. 5.2 falls about there, and 9.3 falls about there, and 0.5 falls about right there, and -10.25 and -3.25 fall there respectively. We have positive numbers on the number line, and we have negative numbers on the number line. There are exact numbers on the number line, like -3.5, 1 and 4. There are those numbers that are not so exact, like pi, square root 2, square root 5, and e, and they too fall on the number line. Exact numbers are called rational numbers, and they fit the form of an integer over an integer. Here we have 1/2. That's an integer over an integer, and it falls about there on the number line, 1/2. But 2/1 is also an integer over an integer, and that's just another fancy way of writing the number 2, and it falls there on the number line. 50/25, that's an integer over an integer, and it's just a fancy way of writing the number 2 as well, and it falls there on the number line. -50/25 is just -2, and falls there on the number line. 6/2 is just a fancy way of writing the number 3, and falls there on the number line. 100/20 is the same thing as 10/2, and that's just 5, and falls there on the number line. If the 100 is negative, or the 20 is negative, then the whole thing is -5. It doesn't really matter where the negative is. It can be in the 100 or on the 20. And the final result there was -5. 7/2 fits on the number line. So we have 7/2 there. And so what we have is that'd be about 1/2. That would be about 2/2, 3/2, 4/2, 5/2, 6/2, 7/2. 7/2 is the same thing as 3.5. -7/2 is -3.5, and 2/2 is just 1. Any number over itself is just 1, and falls there on the number line. If 2 is negative, then it's -1. 1/3. 1/3 is an integer over an integer, and if we did the kind of like top in, bottom out thing on that long division, we'd find that we are at 0.3333, just a repetitive 3 that goes on forever. However, that 1/3 is an integer over an integer, and that makes this rational. Although we have 0.333 as a decimal representation of 1/3, it never actually gets to exactly 1/3 when you put it in the decimal form, but it gets exceedingly close. 1/3 is a rational number, and if we had a -1/3, that's a -1/3. And likewise, that's -0.333, goes on forever. It has a pattern. If we're looking at -8/2, that's just -4. And if we're looking at 8/2, 8/2, that's just 4. Same thing here. Here we have 1/2, 2/2, 3/2, 4/2, 5, 6, 7/2, 8/2. 8/2 is the same thing as 4. All right, rational numbers can be written in the form of an integer over an integer. And Irrational numbers cannot be written in the form of an integer over an integer. Irrational numbers cannot be written, said it there twice for emphasis, cannot be written in the form of an integer over an integer. Irrational numbers are not exact in our decimal system, but irrational numbers do have a place on the number line. There are just as many irrational numbers as there are rational ones. Irrational numbers have a decimal that goes on forever and ever and ever and has no pattern. Pi is a good example. We will never know exactly how much pi is. Correct to two decimal places, we often say that pi is 3.14, but that's only approximately, and it would live there on the number line. And if we'll take a little closer look there, and if we add negative 3.14, it would be there on the number line. And we could say, well, let's be a little more exact. That would be 3.141, or we can look at that and say, well, we want to be more exact than that. We want pi correct to 4 decimal places. That would be 3.1415. And this goes on forever and ever. There's no pattern. That's what makes pi irrational. Square root of 2 is another good example of an irrational number. So we'll take a look at that. But first we'll take a look at what square roots are quickly. 2 times 2, any number times itself produces a product. In this case, 2 times 2 produces the product of 4. That makes 2 the square root of 4. 3 times 3 produces the product of 9. Notice that it's 3 times 3 and 1 times 9. 3 times 3 is 9. That makes 3 the square root of 9. If we have a square, which I've illustrated here with 16 different squares, so we have the square, and we have 16 different squares in that, we see that the length of each side of the square is equal to the square root. In other words, we have a large square with 16 smaller squares in it. Each side of the square is the square root of 16, in this case 4. All right, what number times itself equals 2? Well, if we tried 1 times 1, we'd get 1. And if we tried 2 times 2, we'd get 4. So the number times itself that gives us 2 is somewhere between 1 and 2. But exactly where? Well, let's take a look. Square root of 2 times square root of 2 is exactly 2. Okay, 2 lives right there on the number line. And square root of 2 happens to be correct to 2 decimal places at 1.41. But that's only to 2 correct decimal places. And so the square root of 2 is approximately 1.41. All right, well, if we were to take a look at this and say, well, let's add another decimal. Square root of 2 is approximately 1.414 and can be found there on the number line. If we said, let's take a look at this to a higher degree of accuracy, that would be square root of 2 equals 1.4142. That's a higher degree of accuracy, but it's still not exactly the square root of 2. And so we'll take this, look at this. If I multiply 1.41 times 1.41, I come up with 1.9881. That's not 2. Okay, let's add another decimal. So now I have 1.414. 1.414 times 1.414 is 1.999369. You could do this yourself, or you could just trust me. Now, we look at that. 1.999369 is not 2. It's close, but it's not 2. So let's add another decimal, 1.4142. Multiply all that out, and you come up with 1.999616. That's not 2. We could continue to add decimals, but we would never get to 2. So this is why the square root of 2 is irrational, and some other square roots are irrational as well. They have a decimal equivalency, an approximation that almost gets you to the right answer, but not perfect. This becomes very important later in mathematics. Okay, square roots can be rational, and they can be irrational. All right, let's talk about dealing with negatives on the number line and some common mistakes that students make. If we're looking at 1.1, then 1.1 would be, here is 1, and 0.1 would be just a little bit more. However, the negative side of the number line is similar to like a mirror image. And so negative 1.1 would be, here would be negative 1, and 0.1 would be a little bit more. It would be closer to 2 than to 0. The common mistake is that people will say, this is 1, and I'll put 0.1 here. So this would be negative 1.1, and that's wrong. Here is negative 1.1. If we were to take a look at negative 2.5, we have negative 1, negative 2, and the 0.5 goes towards the direction of the 3. So negative 2.5 would live here on the number line. If we were dealing with the negative 5.02, it would be here. This would be negative 5.2, further away from 0 because our number is getting larger in its absolute value. If we were to take a look at negative 0.3, here we are at 0. We're going towards 1. This would be about 0.1. This would be about 0.2, and that would be about 0.3. All right, negative 5/8 would be smaller than 1. 5/8 is smaller than 1, the fractional form there. It's negative, so we're going to the left of 0 on the number line, and we're not quite to 1. So negative 5/8 would be about here on the number line. All right, negative 8/8. Well, here's negative 8. Negative 8.8 would be over here. All right, your comments, questions, and suggestions are always welcome, encouraged, and appreciated. You may write to me at alanmorris@yahoo.com.